Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is the lecture of IR spectra and lecture number 23. In this lecture I will explain you the instrument with the help of which we take IR spectra, and that instrument is known as IR spectrophotometer. If you want to take IR spectra, then we need a source which gives us IR radiations. So first department or compartment of the instrument is a lamp which gives us IR radiation. So it is a source of infrared radiations. Okay. So this will give us infrared radiations. Of course, we have to put the slit and all to get the beam. And then there will be one department over here which is known as beam attenuator. The function of this beam attenuator is to split IR radiations into two different radiations in different directions. Okay. So first of all, we'll take these radiations, IR radiation, which will pass through a compound which is kept over here, and it is known as reference cell. And polystyrene is taken as a reference to take IR spectra. So when IR radiation pass through this, obviously some of these IR radiations which were incident is 100%, but the transmitted IR radiation will be less than 100% because polystyrene is organic compound and it has certain group which will absorb IR radiations. Now this will pass through detector and then it will go to amplifier, and then it will go to recorder. Recorder has a piece of paper, a graph paper, which will give us a graph. So if we take polystyrene known compound for our reference, then the graph of this would be like this. Here on y-axis we'll have percentage transmittance, so 100% over here and 0% over here, and on x-axis we have wave number starts from 4000 centimeter inverse to 600 or 500 centimeter inverse. Okay, and now polystyrene will give us three major bands, one at 2850 centimeter inverse, another will be at 1603 centimeter inverse, and one will be at 906 centimeter inverse. This 2850 is due to CS stretching, 1603 is due to C double bond C stretching, and 906 is aromatic CS bending. Okay, so these three are the important bands which we observe when we take polystyrene IR spectra. Now what we have to do, this is another compartment which is known as sample cell. So the now next beam will be passed through both. So next experiment is, here we will pass IR radiations through reference as well as through sample, which is unknown compound, and we want to take IR spectra of this unknown compound, which is kept over here. Okay, and then we run this. So here definitely intensity is 100% over here for IR radiations, but when it passes through sample, it will be less than 100%, and this will also give us our IR spectra in recorder. So for IR spectra of recorder with sample and reference will be like this. Here it is the same percentage transmittance, and this is wave number. Okay, we have three main bands due to polystyrene, and that is at 2850, one will be at 1603, another will be at 906. Okay, these are the main important bands of polystyrene, and this we will neglect it when we take when we refer or when we study this IR spectra of sample. We know that these three bands will appear because of polystyrene. Okay, but this is for calibration. Now along with this, we will have many bands due to some functional group presence in IR, maybe like this, and this may be the IR spectra of sample, okay, in which you find red band is due to reference. So that is overlapping of reference. And green spectra will be the bands of functional group present in sample. Okay, so this is known as spectrophotometer. With the help of this, we can take IR spectra of any unknown compound, but first of all we need polystyrene for calibration. So that is very important. So this graph is for calibration of instrument. Okay, so first of all we'll have to run this instrument for only polystyrene for calibration of instrument, and then we can run this sample along with a reference compound, and we can get pure IR spectra of unknown compound with accuracy. Okay, next thing, the most important is sample making. Okay, so here it is very important to prepare sample for IR spectra, and this topic is known as sample handling. That means preparation of sample. That is preparation of sample of unknown compound of which we want to take IR spectra. So normally organic compounds are in three different states. One solid, then we have a liquid, or maybe gaseous state. If organic compound, unknown organic compound is gas, then it's easy to take IR spectra. What we have to do is to expansion of gas in sample region, sample cell. So with the help of this, we can take IR spectra of gas directly. If it is a liquid, then sample is prepared of liquid with the help of two plates of sodium chloride. So liquid is kept between sodium chloride plates. Okay, and if it is solid, we have to prepare this as mull or press disc, or we can prepare a glassy film. Okay, so this way sample handling is very important topic, but I think in detail I will explain you in next lecture. Thank you so much.